My name is Mark Williams, work for the Boeing Company, and I'd also like to acknowledge Adrian Murton. Adrian is an Airbus employee, and together we worked on this presentation during a series of workshops with numerous companies participating across the globe. I do not have a webcam, and so this is the best you get. And this is about 35 years ago. The main picture, my current shape is in the bottom right-hand corner. So portable computing was what we had, and we did share our models. This is my digital transformation that began over 30 years ago. We didn't have desktop PCs, but we created reusable numerical models on magnetic strips that we called cards. There's a little sample up there by the calculator. We communicated with mainframe applications via a modem, and these magnetic strips, these cards, were kept in a shared binder, and we collaborated by testing and updating each other's cards. And this is how the engineering journey began. So first I need to recognize our sponsors. Adrian and I were the leaders for the MBSE LOTAR and PDIS teams. PDIS is the product data exchange specification, the STEP specifications, LOTAR long-term archiving, LOTAR International. And the sponsors of LOTAR and PDIS are the AIA, the Aerospace Industry Association of the U.S., and the Aerospace and Defense Standards Organization of Europe. And those are the leaders that authorize the LOTAR and PDIS activities. And we also have partners, AFNet of France, NAFIMS worldwide, ProStep IVIP, predominantly Germany, but across Europe, and INCOSI, a worldwide organization for systems engineering. And this is primarily what makes up the leadership of the LOTAR and PDIS teams. But we also have members from many different aerospace companies that also contribute. So, like I said, as we started this digital transformation, and we have committed ourselves to change. On the left, the legacy process, where many of our models were federated and linked to specific documents. And documents describe the models and manage the requirements, the functions, the behaviors. But today, on the right, the goal is integrated models. So for the last 20 years, 3D CAD has generally been an exception. But we were still reliant on the bill of material to provide more model details. The graphics was the drawings, the features of geometry were not enough without the BOM. So the biggest gap in our process was during the conceptual design development phase, when all the important decisions were made. Why does the shape look like that? Why are those parts combined? And we lacked the tools and standards to share those initial requirements, architectures, and simulations without documentation. So, assuming today that we have completed or are well down the path of our digital transformation and have conquered the authoring process, so now we can author many different types of models, and we have revealed several new PLM changes. How do we extract the value out of our digital transformation? Our first assumption is identifying what data to integrate. How do we share our models both internally and externally? And when we share our models, each consumer needs to know what was its purpose, what was its history, its pedigree, its provenance. And the truth is that if you step back and look at each model or observe someone else's model, it's really only the author that can specify the model's intended purpose. So in the past, this problem was kind of simple. We had documentation, and everyone could read the documentation. But our products continued to grow in complexity, and no one can read and understand everything, especially the dependencies. So the solution providers listened to our prayers, and they gave us PLM. But what are the characteristics of PLM? Buckets of data, all from unique domains with many complex formats. And we are still learning. Within the PLM, the integration techniques are new, and finding the right data can sometimes be very difficult. We have these issues of the diversity of the models and the terminology that describes the models, or what we all use different words, different vocabularies. And how do you archive these models and make them available? And of course, the life cycle of the tools. The tools are constantly changing. So the model's purpose. Every model has its own representation, description, and we need to think about how to decompose the contents of every model and expose them to the PLM system so people can find them. And we need to have some type of manifest, a bill of lading that classifies the model's characteristics, what it's intended to do, its scope, what vocabulary is engaged, and how to manage the relationships. So technology is great. Now with these new PLM systems, we can expose and link each object in the model across the entire PLM system. Now I have millions of links, and I use the PLM system's provisions for change. I can manage change. However, now I receive thousands of notifications that my links have changed because my model and other models have been revised. We better be prepared for more PLM technology innovations. Our proposal to the PLM vendors should always be to keep it simple. So my suggestion, capture the model's essential data and link those results. Let's consider the problem using the Einstein method, a mind experiment. So in his experiment, millions of planets, multiple sizes, multiple distances, multiple universes. This is to follow the NASA presentation, so hopefully we get back to it. But in our version of the experiment, our digital transformation represents multiple universes. We have conquered the authoring systems, and the models are the planets. And we have added PLM as the map to the universe. The goal is digital twin, so let's run a simulation. Let's start with a SysML architecture model, a MATLAB dynamic model, maybe some mechanical physics. Let's look at the fluid thermal characteristics, and don't forget, these are complex systems, so we're dependent on software. So now we have multiple model types, each with their own specific purpose, their unique functions. They share parameters. They have simulation interdependencies. And this is my digital transformation, and it is governed by the ability of the tools to use each other's results. And these tools help us specialize so that we don't lose the details. So the stakeholder, their expectations are that the functions are common across all the designs. And those detailed component functions have been derived to define specific modeling needs. Believe me, all of these formats are unique. And to maintain those relationships, they must share parameters and remain synchronized. Get one of them out of whack, a few changes, and the rest of the models will suffer. Together, they represent the simulation, the behavior of the product. This is not a test. This is the digital twin. So in addition to verification and validation, we use simulation for causality, for prediction, in order to make decisions. So the three major challenges may include defining the model relationships, how the co-execution of the simulation by different domains can be utilized by the different tools. This is the effective use of simulations for collaboration. This is the PLM challenge. So how does your PLM system help you measure integration? Every one of you think right now, can you identify your favorite integration process standard? Is your integration process formally recognized as a standard? We have published process standards for software, for networks, for safety, but the choices are few when you consider a diverse set of model types. Everyone has their own idea of how to integrate engineering models, but shouldn't we be using a repeatable, documented process? So these are some of the characteristics from the Savvy project of how to measure model consistency. And you always want to run a consistency check when you're engaged with multiple models. And then perform a credibility assessment per the NASA standard 7009 that Martin was going to talk about. The goal is consistency and credibility. But also note that one of the repetitive themes in these consistency checks, in these credibility checks, is metadata. So how do we integrate our models? Let's talk about metadata, that information about the data in the model. It's a formal classification system. There are discrete classifications that are expected when you define metadata, and digital metadata is a key to data interoperability, to the exchange, for translation, for reuse. The metadata baseline for digital storage archiving is called OIS, that ISO spec 14721. And it describes metadata in detail, specifically for archiving, for managing that model. And that's what metadata is, a tool to manage the data, the models, the repositories, and my simulations. So this evolving digital landscape, this digital transformation is driving the relevance of metadata. More details, as previously described, descriptive, structural, statistical. There's legal metadata. That's your IP. That's your copyright. So one of the challenges is a classification system that takes advantage of this metadata. And our biggest challenge now could be vocabulary. Everyone describes it a different way. So here's another example. Numerical behavior models. These are the math models. And so if you examine them per the physics domains, is it classical mechanics? Is it quantum mechanics? Is it high energy particle physics. What is it that you're representing? And then once you describe the physics domain, how do you describe time? There are many different ways to talk about time as a discrete scale, hours, minutes, seconds. Maybe it's a finite different method. So there's real challenges in all describing, using a common vocabulary and then understanding it. So just think about it. We don't all speak the same language. And especially when you look at our worldwide set of suppliers. So the teams worked on trying to build a classification prototype. Classifications describing the system, the domain, the method that was used to create the model. So you can see that there are many different ways to describe method. There are many ways to describe model fidelity. And we're getting closer to that vocabulary, but this is just a sample, and the problem is still too subjective. So we go to the standard, we go to OIS, and they call it content information and preservation description information. And the 4 major categories of provenance, reference, 5 categories. Now because we have added access rights, it's now important to be able to protect the data and control its use. So the OIS standard addresses an organization of people and systems. And this picture is the preservation description information. And it isn't just for preservation. It should also be used for how you originally store the model when it's available for someone else to use. So let's examine one of these categories. Let's just talk about reference information. Includes the model identification. So we have some type of part number. The model has some type of role. Maybe we've described not only the part assembly installation type, but we've given it textual names of this is a pump and it's used on the wing and it's used for the right-hand engine controls. And the model description purpose may be part of the model text, a separate set of identifications as to how it was, approved, or that it was specific to consumption during a specific derivative. And then we need numerical identifiers beyond the part number because it needs to be stored in the database. So there's a UID or a UUID, and then we need to link it. So expect to have a URI schema, some type of location service identification like your web URL. Oh, and it's got a configuration. This is the 3rd or 4th version, and it's been approved. There is lots of reference information that you may not consider when you create the model, but needs to be part of that model when you are sharing it or storing it. So we have a good reason, a good business reason to consider how to manage this metadata. We need to be able to search for each other's models. We need to find the correct model. We need to recognize when you have found the correct model. We have this data obsolescence. Every model needs to have a purpose. Every model needs to have a relationship. And how is that described in the PLM system? Just by a link? But we have this need to collaborate. So it may not be just a single model that we need for collaboration, but a package of models, each with their own link methodology. Includes a history, what's changed. We need to track that change and be aware of the vocabulary. do I understand what the author meant when a particular phrase was used? And we need to not only support our latest, our newest data, but real value comes from reusing some of my older data, and that's important. So let's look at the industry. The IDC, the International Data Corporation, said that each employee spends 2.5 hours searching for information every day. And this is an industry survey, not just aerospace. And this was many years ago, 20 years ago. In 2018, now we're in the digital age, and the IDC said that that number has grown from 2.5 hours to 30% of your day is spent looking for information, existing information, and that rises to 50% when you add preparation, reuse, and duplication in order to take advantage of existing data. Another statistic, a big full-service enterprise that includes engineering, manufacturing, and services, the data explosion is enormous of what you need to be able to search for or search through. There is more than one metadata standard. In fact, the entire list, there's about 24 that we've counted so far. And you see that OS is in the middle of this list. But now we're talking about engineering models. So let's kind of focus on metadata standards for engineering. SystemX, a company that works on engineering technologies, created the Model Identity Card. So here's your index card in the card catalog defining the model. INCOSE has its characterization pattern, in that there is not just one model, always assume there's multiple, and that pattern is what that connection is, and that's how that standard's described. There's the new ASSESS initiative, the Unified Model Characteristics, working very hard on it, a great team of experts, usually focused on simulation and analytical content. ASME, of course, 14.47, the standard for metadata. And it is a little long in the tooth and primarily focused on CAD-BOM relationships, but it is being extended. The Object Management Group, they have this pedigree provenance notation. And of course, the web people, W3C, they have their own. So you can read this list, but I want to take you to the bottom of the list and where we describe MOSSEC, a new step standard, AP 243, modeling and simulation collaboration in this engineering context. So to look at some of these standards, the SystemX MIC, it's really not generic. It's really focused on numerical models. It is more at a component level instead of a system or a system-to-system interface. It has limited control over the process, so it may not cover all the areas that we need. Some similar comments for the MCP from INCOSE. It's kind of obscure. You really need to understand how the models are created. It's dependent on a higher level architecture to connect the models, and you must have good PLM system automation to take advantage of it. And it is not currently classified as an official standard. But the ASSESS initiative, hey, we do not have enough engineers with the expertise needed to create the models, let alone integrate the models. But this particular set of metadata is very promising, but somewhat specific to the mathematical domain. I mentioned the ASME standard. There are 4 pages of optional or required metadata for every model. And it is really suited to a combination model documentation representation, and many of the attributes are very aligned to CAD and manufacturing. So there is ontological methods. Once again, if you have a big computing system, PLM, this is the way to do it. However, sharing models outside of this context could be difficult since it's mostly an in-house PLM system. But now we talk about MOSSEC. So this is a new standard. It manages those links across multiple domains, and it was designed for collaboration both internal within your enterprise and externally. But it relies on the vendors to help us integrate the capture, the visualization, the ability to edit the metadata, and the benefit really improves if this data is exposed to the PLM system, not just to the user of the model. So you'll need some type of viewer in order to be able to inspect the model's metadata. But the premise is based on an instance. And that model instance could reside in multiple places. You could have the one within the enterprise. You could have a copy that you shared with more than one supplier. So managing that connectivity and how it was transformed or exchanged and what you really need, what is the most important feature, that information that you need out of that model or that you need out of that metadata is readily available. So here's an example. This is a prototype. Actually, this is a new LOTAR publication that is being written, in that you use a standard, in this case MOSSEC, you create your model, and from that model, since the vendors haven't implemented a metadata methodology yet, you create a manifest. So here's your BOM, your MIC, and now you can generate a representation of the model that you're going to store and share and put it in a repository. And in that repository, now we use the term AIP, that Archive Information Package, that comes from the OIS standard, and that describes the model in the repository. So in this case, the models are called FMUs, FMU number 1, number 2, and there is an AIP that not only describes each model, but describes the relationships of the model. And so now the user can examine the AIP and say, that is the model that I need to use for my simulation, or to make a change, or to complete my integration task. So I go back to the challenge of the multi-model use set. So this digital transformation is governed by the ability of the tools and the use of the results. The tools help us specialize. The tools are important, but we need that, satisfy those stakeholders' expectations. We need to understand what the vocabulary is. And so the three major challenges is maintaining the model relationships, the execution of the, I have a call maybe from Martin in Florida.
So this is Kenny. We'll take a pause. It sounds like we're trying to get Martin connected back up to our webinar.
Okay, that was Martin. He is still trying to connect. Some Bora Auralis somewhere down in Florida has caused great challenges. Hopefully we hear from him very soon.
That's great.
I'm sorry to drop you off, but we are trying to maintain the model relationships, co-execute the different simulations from all these different domains that use different tools and come up with an effective use of the metadata describing the simulations for collaboration. So we can accelerate this digital transformation, this transition to model-based engineering across the enterprise. And we can measure the value of our data if we emphasize that identification and integration process. Now, I didn't describe integration processes. Instead, I described the use of metadata to start the journey. Don't forget it. Don't be challenged by the need to describe your model to someone else and to make it part of the model, to make that description part of the model. It is more than text. In the MOSSEC implementation, it is real, live, descriptive model data. So go to your solution provider, your PLM server, and ask them to share their MOSSEC strategy. How can you do a better job of managing and utilizing the metadata? So that's all I have. Lily, can you help me? Do I have some questions maybe from the audience, or maybe I stunned them?
Mark, I don't know if Lily's on, but there are some questions, so let me quickly share some of those with you. I guess until we see whether or not Martin comes back. Okay, the first question is...
I see one of them. Mark was talking about 3 challenges, but only mentioned one before taking the call from Martin. Did I not finish that sentence? I thought I came back and finished it. So I'll go back. Maybe. No, come on, back. So the 3 main challenges: maintaining the model relationships, the co-execution of the simulations by the different domains who use different tools, and how we use simulations described by metadata, or forget the simulations, how do we use our models described by metadata for the collaboration process? Those are the 3 challenges: the relationships, the differences, the diversity of our models, and an effective use of those models for collaboration. So I hope that answered the question.
Okay, Mark, we have another question for you. Can you hear me?
Yes.
Okay. Could you explain a bit more about the emerging AP243 MOSSEC standard and why you see it as a potential game changer?
Okay, sure. So MOSSEC is made up of multiple parts that comprise the STEP standards, and it is integrated with other STEP standards. And so these STEP standards are special. They expose that digital model in order to make it much easier, a standard way by which to exchange them and interpret them, regardless of what tool you're using, regardless of what environment. And so they are built on what's called the core model, and that's ISO 10303-4000. MOSSEC is built on 4000 also. MOSSEC has the web services built in. And it's kind of a first in terms of exposing web services across the STEP standards. So now you can link relationships between multiple models, between multiple PDMs. So this is an important feature so that you can keep track of your model regardless of which PDM it needs to be stored in. In this picture that you're looking at, these models often require specialized PDM capability. I don't store my software in the same place that I store my SysML models, in the same place I store my MATLAB models. Those are unique repositories because special characteristics are included in those repositories. And so including, and this is step, all of them are 10303, including step -18 for web services to keep my models connected is an important part of MOSSEC that is unique to the other metadata standards.
Thanks,
Hey,
Mark,
Mark.
for answering that.
Martin just came back on if we want to try and send it back over to him.
Good. So how much time does he have left, Cheryl? Can you help me?
I think he probably has